Okay, in this video, I will explain a material from one of the stationary wave. So as you know that stationary wave has two types. There is bound end and free end. And today, I'm gonna explain about the bound end. Okay, so for those of you that don't know what kind of wave it is, so this is what we call a bound end wave here. So as you can see here, the wave comes from the point over here. So it resembles like if you have rope and just tie it up to a pole and just make wave from the rope. That's one of the type there, which actually started from the point over here. Okay, and I'm gonna explain it in English. These texts are in Indonesian. So this side here, where it goes to the forward side, it called reflected wave. Okay. And this one here, which going to the point itself, is called upcoming wave here. So we have two types of waves here, but I'm just gonna divide it into two, which this wave is C and this wave is B. Now what you see, this like a pole here, it's called Y, or usually we call it like derivation here. So if there is a derivation, which is a in this problem, we have Y here. So we have two things here. We have the derivation of the upcoming wave, and we have the derivation of the reflected wave here. So in addition of that, this is one of the problems before we go to the formula of the bound and stationary wave itself. Now from these two different type of Y, we got two formulas here. So when we got the YC, we have a amplitude times sin, and by times of omega times time minus kx here. Okay, and for the YB itself, it's almost same, which is YB equals to amplitude sin omega times t plus k time x. So these are formulas for both of the derivation here. So you might want to ask, why is it different? Why does the YC has minus and why does YB has plus? So the YB is actually the reverse wave. So it's actually should be a negative formula, because it's negative, it turns into a positive there. So actually it is a same formula as this, but it is the negative one, so it becomes omega t plus kx. Right, so from these two formulas, we can actually make the total of the derivation itself. So if we combine here, if we have like a y, if we have y here, we just wanna put it together, which we add it. So y equals to yc plus yb here, but it more complex than before actually. Okay, so you just wanna put the formula inside, which this is a times sin times omega t minus kx here, and this just gonna have the same formula here, which the YB here, and this one is add here. Okay, now from this formula we saw mathematical problems here, which is trigonometry. So this problem here is same like sin alpha plus sin beta equals to 2 sin times to alpha plus beta divided by 2 and cos alpha minus beta divided by 2. Okay, so before we make it as a trigonometry formula, we're just gonna take out the amplitude first. Okay, now that we have amplitude is out, we're just gonna take the formulas into trigonometry formulas here, which if we just turn it into formula itself, it will be so here we will get a times 2 sin, it's sin kx cos omega t. Okay, now from this you can just put the 2 out, which we're just gonna put it here first. We can just turn it into 2a times sin kx times cos omega t. And so these are the formulas for the total derivation here. So I'm just gonna leave a mark here. Okay, maybe I'm just gonna write the better text there. Okay, now so if we have this formula here, this is called the resultant of amplitude, or we call as AS here, which is the 2a sin 2a times sin kx here. So these are the common formula for the bone and stationary wave here. Okay, so we are going to continue our material here, which is the node and antidote here. So at the top side of the image is a node, and on the bottom is the antidote. Okay, so the node itself is counted from the points of the wave itself. Okay, so as you can see from the arrow itself, the point is where the node itself is counted here. So from the start here, we have the bone end here. It is counted as the first node, and it is equals to 0. It is equal to 0, and continue to the other point with second node. It is half lambda. So the lambda here is still in because it is the long, how long is the wave here, and it is counted as a half here because it is from point to the point. Okay, and it is going on until the end point. Like the third node, it is 1 lambda or lambda, and the fourth node, it is 1.5 lambda, and so on. For the antidote itself, it is counted from the valley to the hill. So you see the first arrow here, it counts from the alley here, from the node, from the point of the bone eye into the valley itself. It is counted as 1/4 lambda. When it goes to the second antidote, it's counted as 3/4 lambda, and to the third antidote, it is 5/4 lambda. So here, as you can see, we start from the quarter lambda, and then start again to half, and so on here. So from what I explained here, we can see a pattern here. Okay, and from this pattern we can actually make a formula from it. So we're gonna start from the note itself. The formula of the pattern is xn equals to 2 times n minus 1 times a quarter lambda. It is, and for the antidote itself, it is xn equals to 2n minus 1 times quarter of lambda. So it's actually different, almost a different formula. It just have a different position of 2 here, as you can see from the pattern itself. And the n itself, it must be a real number, which is 1, 2, 3, 4, 5, and so on. So I have a example of question for the bound and stationary wave here. So a rope that has 250 meters are pulled away horizontally. From the end of the rope, they give him a wave which has 2 hertz of frequency and 10 centimeters of amplitude. But the other end is tied to a pole, and the wave moves at 40 centimeter per second. So the question A here: what is the resultant of the amplitude if the point is at the distance of 132.5 centimeter from the first point of the wave? And the second, what are the y's if the rope itself is wave for 5 seconds and 12 seconds? And third is what are the position of the 6th note and the 5th position of the antidote? So we're gonna answer the first questions to find the resultant of amplitude itself. So we need to find the real distance first, because from 250 we can just subtract it with 132.5, which equals to 117.5 centimeter. Because the point has distance 132.5, so we need to subtract it with 250. And we're going to the formula of resultant of amplitude, which is 2a times sin time kx. But in these conditions, we have phi and lambda here. So we change the formula to as equals to 2a times sin 2 phi times x per lambda. So we just put in the numbers here, which is 2 times 10 times sin 360 times 117.5 per 20, and it equals to 20 times sin 315, which is equals to 10 and root of 2. And the second questions, we need to find the t itself, which we can find by 250 plus 170.5 per 40, which 40 is the velocity of the wave itself. And as we can see, we have 9.2 second here for the time. I'm just gonna put the formula here, which is y equals to 2a times sin kx times cos omega t. And we already know the 2a sin kx is the as, which is 10 times root of 2. And we're just gonna put in the 10 times root of 2, and we also get the omega, which is 2v, and time itself is 9.2 second, or we can just put it like 12 per and half. And so we get here 10 times root of 2 times cos times 48 phi, and from that we get 10 times root of 2 centimeters. And for third questions, as I said before, for the formula, we have for the note here, which is the 6th note, which is that means we can just put x6 equals to 2 times 6 minus 1 times quarter lambda, which we can find here that 2 times 6 minus 1, 6 minus 1 is 5, so and times quarter lambda, 2 times 5 is 10, and that means the answer is 5 per 2 lambda. And for the antidote itself, we're just gonna put in the formula, which is x5 equals to 2 times 5 minus 1. So 2 times 5 is 10, and minus 1 is 9, and times to 1 a quarter of a lambda, which is 9 per 4 lambda. And that's all of the questions are solved.